This is Chris Myers, right?
Yes.
Chris Myers is the lab director?
Lab manager.
Lab manager for, tell me?
The Citris Invention Lab at UC Berkeley.
At UC Berkeley. And tell me a little bit about who you service in terms of bringing to your lab, in terms of the kids.
We're a campus makerspace, and we're open to all students. And we also host classes in here from a couple of different departments, mechanical engineering, computer science, new media, but we're open to all students.
And you introduced this nice...
Oh, the art box.
The art box.
So we have the SpinBot. This is a SpinBot, which basically teaches kids how to, what a circuit is, how to wire a circuit correctly with a battery, a switch, and a motor, which is the power, the control, and the actuator. And it goes together with zip ties or rubber bands, and it's configurable. You can put it together a couple of different ways and see what you basically physically program it, see what the layout of the body, how that influences what it draws. You can attach pins or crayons or chalk to it, paintbrushes, anything that can leave a mark. Hopefully washable. I don't recommend Sharpies unless you want a permanent work of art. It has a small rubber tube, textured tube for a wheel, small diameter wheel, but you can replace this with a blob of glue, with a small cut up piece of eraser, and that'll affect the pattern of it. Basically it works on the motor and the wheel. There's only one motor and one wheel, and it's off axis from the center of gravity, so it'll spin it in a circle. It'd make a perfect circle, but the drag of the tips affect that, and so that influences, and teamed up with the direction of the spin, it makes a nice precession pattern across a page. If everything's equal, the paper is flat, the floor is flat, or the tabletop's flat. If there's some disturbance, like a bump in the floor, or a tear on the page, or it will upset that and can settle into one little spot. As the pin tips wear down, it'll do a little bit of different size pattern. You can extend the pins. I like extending one pin out and one pin pretty close, because that will change the size of the circles. One will tend to be larger and one will be smaller. You can move the motor from the bottom of the leg and zip tie to the top of the chassis. And if you put a eccentric weight on there, hot glue a nickel on there, or push a pink eraser on there off center, the vibration of it will turn it into a vibrobot, which basically vibrates and moves across the page.
So tell me a little bit about the physics of that mechanism you have there.
The center of gravity is right in the middle of the robot, and having the motor off to one side, it's that distance which basically wants to make it rotate about the center of gravity. So it's just going to spin. It's a SpinBot, and depending on you could put two batteries on here if you wanted to make it spin faster. If you put 3 or 4, it starts going so fast it'll start splattering the ink a little, more like a spin art.
Oh wow!
Which is pretty cool if it's washable. You can actually change the angle of the motor, so now not only is the motor off axis, but the rotation is now not lined up parallel. Well, parallel is not the right word. It's perpendicular to the center of gravity, and so now it will actually change the size of the circle.
What about? I noticed there are some red things and yellow things that's sticking off that. What are those?
So this is held together by zip ties, which is great. The wiring is all color coded, so the children put together, they have to actually physically twist the wire together. So they take the bare ends, twist together. This is called a wire cap or a wire nut. And these are really cool. There's a little tiny metal spring inside, and it basically grabs onto the wires as you twist it on and holds them together and keeps them from shorting out or coming apart. which is nice. And there's a couple different colors on here.
And that is, why do I need the red and the yellow? And how does it relate to that big black thing on the top?
So you have a battery here, and to get the power from the battery to the motor, we have to, there's a positive and negative. The motor is actually, it can work either way. The polarity doesn't matter, but it will influence the rotation. So if you reverse the polarity, it'll reverse the rotation of the motor, which is sometimes fun to do to see if it acts differently. So if we take the red wire from the battery, we can actually control it by putting a switch in. And what a switch is basically like taking the two wires and pulling them apart. There's no longer a circuit. And the circuit basically has to be a loop connecting the battery to the motor. And so the electricity will go through the red wire up to the switch, and if the switch is pushed in, it connects the red wire to the yellow wire, and the yellow wire is connected to the yellow wire from the motor, and from the motor it goes to the black wire all the way back to the battery, to the negative side of the battery, so that completes our circuit.
Very nice. Thank you so much. And one last question. I find it interesting. What are those yellow things that's holding?
So
yeah, what are those?
A couple different yellow. There's green and yellow. There's rubber bands holding pens on. So the rubber bands provide an easy way to hold the pins on. There's also some rubber bands holding the legs on here. There's a zip tie holding this leg on. So I like the rubber bands. It makes it a little bit more like a suspension on there, which can add to the effect. So it's a good experiment on. You can actually put these together with pipe cleaners, twist tie them together with pipe cleaners through the holes. That's pretty cool. The zip ties are great because they hold on things really tightly, and if you want to remove them, you can just cut them off and use another one.
Wow. Well, this has been really nice. I thank you for your time, and thank you.